Welcome back to more dplyr basics or basics of data manipulation with dplyr. So we had just finished in the last video with the summarize function. And so summarize, again, applying a summary function that creates a real valued statistic. Okay, so by itself, it's not, I usually don't use summarize by itself because it hurts more than it helps in basically creating this one-by-one tibble that's just x bar, that's just the mean, or really whatever you want of a column. And so it's usually used with this group by argument. So group by is a very powerful function that allows you to do conditional computation. And so we're usually going to use group by together with summarize to create statistics for each group. So for instance, in my fakish grades data, it's at the beginning it's one column or one row per student. Now eventually that's not going to work quite for us by having one row per student. We're going to have to there are a number of ways to do it, but the way that I'm going to suggest that we eventually do it is that we're going to have to make the data a lot longer. We're going to have to change the shape of the data. And we're not going to have one row per student anymore. We're going to have one row per assignment. And so we're actually going to have 23 rows for student 1 and 23 rows for student 2, 23 rows for student 4, so on and so forth. And so that makes using summarize alone not helpful at all, but we can then group by. So we can group by the student and do computations only on that particular student. Or it does a computation for that student and only that student, then moves on to other ones. So let's see what that does. So group by enables the popular split, apply, combine strategies seamlessly. So what does that mean? It means it's going to split the data set up into a bunch of tiny data sets, apply the summarize function to each of the tiny data sets, and then combine all those results back together into one big summarized data set. Okay? So, for instance, I have our diamonds data set. So our small data set won't quite do. Okay? But I have a diamonds data set down here at the bottom. Remember, that's a data set that we have seen before. And so we start with diamonds. There are 5 different cuts of diamonds. Fair, good, very good, so on and so forth. I can't remember them all. But what I want to do is find the mean price for each diamond cut. Okay, mean price for each diamond cut. So there are 5 different cuts. I want to find the mean for each of them. Summarize by itself, if I just took the data and I said summarize mean is mean price, so I took out that group by, it would give me one number, which is the mean of all of the diamonds, which is interesting, but not as interesting as the mean for each. Okay, a question that I could ask is, a bigger question, does cut affect the price of a diamond? And you would think probably the better cut diamond should be worth more. And so one way I could try to attack that question is find the mean price of each cut. And so that's how I would do that here. Okay, fair, good, very good, premium, and ideal. So I forgot those 5, but that's how it would happen. And so you see, you could have, instead of one price, you have the mean price for each of them, which I think is very helpful and we will use a lot. Now, I had discussed previously in the last video, mutate and mutate variance. There was also select variance and a few different things. And especially for mutate, I talked about how they were old. The mutate variants were superseded. What were they superseded by? They were superseded by this function, across. So across allows you to apply the same transformation to multiple columns. So it's the successor to mutate and summarize variants, and thus is usually used inside mutate and summarize. Okay, so what does that mean? How does that work? Okay, so before, so here I have the tibble. It's piped into mutate, so the first argument is mutate, and then it takes, remember, the ellipsis, the triple dots. And so what that the triple dots is now taking in is this across function. So across x colon y, I want to find the mean. And so what that's going to do, instead of having to write two separate mutate calls or two separate arguments for x and y, so x equals like x bar equals mean of x, y bar equals mean of y, something like that, I can do this. And I get the mean of x and the mean of y. Now, it's not exactly probably what I want for summarize sake, if I were summarizing, because it then just repeats that number, which was, excuse me, the mean of x and the mean of y down all 5 rows. So that's probably not very helpful, but hopefully it does show you what it would do. That's sort of putting together mutate and summarize all in one. Okay, but now I get something like this, which is a more intricate example. So there's a famous data set called the iris data set. And it has measurements on 3 different types of irises, 3 different species of irises. And it has measurements on 4 things. There's sepal length, sepal width, petal length, and petal width. Okay, so what am I doing here? Well, I'm taking the iris data set and I'm grouping by the species. So I want to do a conditional computation on each of the species. I want to find the mean and the standard deviation of each species. Okay, and I want to do that for each of the sepal columns. So there were 4 columns: sepal width, sepal length, petal width, and petal length. So I want to do something. Well, it turns out mean and standard deviation. I want to find the mean and standard deviation for both of the sepal columns. And that's one way I could express that here. Okay, and so what did it give me? Well, it gave me, for each of the species, Setosa, versicolor, and virginica, so three rows, and it gave me the mean and the standard deviation for both sepal length and sepal width. Okay, hopefully that makes sense. We won't really be using across a lot, but I wanted to let you know that it is there. A second, even more recent than across is now fairly old, but it was new for the spring 2023 students, I think. A new addition is that inside summarize, also note that summarize is spelled with an S and also a Z, so you can use either of them. If you look up at the pop-up to the left of where it gives you all the options in the sort of yellowish bar, you can see summarize. The first argument is the data. Second argument is ellipsis. Then the third argument is dot by, and the fourth argument is dot groups. So they've implemented recently this dot groups argument, and I think dot by. Actually, let's look at this. A way to look at it is to put a question mark in front of the function. Okay, and then come down here, and they they tell you all of the arguments. Okay, and so if you look here, the dot data is this. Okay, here's the ellipsis. Again, I said there are some parts deprecated. Here's an experimental. This is new, so this is experimental. But this dot by argument is a way to group by without having to use the group by function. So before I showed you, or I gave you, so we're going to use this down here. So we were, in our group by example, we used the diamonds data set that looked like this. And I said diamonds group by cut. Okay. Summarize mean price. What do we call it? X. Okay. And so I showed you that. Now, there are a few things here. I used, so you say, Dr. Inners, what the heck's going on? I have a vertical bar and a greater than sign here, and it is not this. Okay. There are two different pipes. Recently, R put in a native pipe. So before, for a long time, for many years, the pipe on line 31 was the only pipe that existed, or the only pipe that could do this. And it only existed in the tidyverse. Somebody had to make it, but the R language itself, base R, did not have one. But the use of the pipe became so pervasive that base R put in a pipe. And so that's what this thing here is, the Magritte pipe on line 31. What I'm using on line 32, 33, 32 and 33, that's the base pipe. There are differences, and we won't get into them very much, okay? Later, if at all. If we do, it'll be later on. I changed mine, so if you go to Tools, Global Options, Code, and you look here in this General tab, use the native pipe operator. You can check on or check off, okay, if you want to use the Magritte. If you don't do this, it'll default to the Magritte pipe. But if you do this, it'll go to the native pipe. And you might ask, I still have to type it in. I don't default it. Well, there is a keyboard shortcut that is Shift Control if you're on a not Mac, Shift Command if you're on a Mac. So Shift Command M or Shift Control M will give you a pipe operator. So that's a shortcut if you don't want to type it out. But anyway, there are a few things here. I use the S instead of the Z, and I use this native pipe. Okay, now back to why I started this tangent. Instead of doing group by and summarize, I can use summarize. Okay, X is mean price. And I put that argument there, and I get the same thing. Okay. Now in actually a different order, but that doesn't matter too much. Okay. There are some reasons why you would do this. The biggest reason is that when I start to use group by, it changes underneath the hood. Not that you're going to see it very often, but when I use line 33, the 32 through 34 line to get this, the actual result, the thing that it prints out, is a grouped tibble. So that like the grouping persists even after you run summarize. And you might not want it to exist after you run summarize. You might want to do something different to it. And so to get rid of the grouping, you'd have to add another function that we'll see, ungroup, to get it ungrouped. Okay, now it's not going to change how it looks very much, although it does change it slightly. If you see, no, it doesn't. Sorry. So it doesn't change how it looks, but underneath the hood, things actually change. When I do the bottom, now line 36 and 37, it groups, it does it, and then it also ungroups at the end. So you can do either. I will probably do line 32 through 34 more often. Okay, but this is a fairly new experimental thing that is happening in here. So if you like that, if you like the way that looks, the way that feels better than this, then by all means do it. Okay, so anyway, this is a cross, and that made me think of that. So sorry about the aside. Now, there are lots of other functions. Those are the main ones, and I've already talked for way too long about the main ones, but here are a bunch of them. So count is a special way to summarize and look at the length. Okay? It's a group by summarize that is counting the number of things in each group. Ungroup removes the grouping, which I just talked about before. Okay, and then there's a few other ones. Pull is an interesting one that will select a certain column. So it's like select, but it then turns the result after you select. Usually when you select a column in a data frame, the result is still a data frame, still a tibble. But if you don't like that, pull will select the column and then it'll turn it into a vector and return a vector. So that may be helpful from time to time. Okay, there's transmute. Transmute is mutate, but then it drops all the other columns. Just these things that you use the basic one, you wish, well, I really wanted to do this. There's probably a function that does the thing that you really want. Okay, and then there's even more. Okay. The bottom one, there's lots of, so not the bottom thing, but the long list of functions, bind, calls, full join, semi-join, left join, right join, inner join, those we will actually talk about in a separate video a little bit later on, about joining data frames, tibbles, data sets together. Okay, and I included a link here that you can find all of the dplyr functions. Now, also, the last thing that I'll mention, it's really popular, okay, and it does have some downfalls. The downfalls are that it's slow. The downfalls are that it's really slow compared to some other things. And so if you really care about speed, we're not going to. dplyr has one major competitor within the R world, and it's called data.table. Data.table. And data.table is very fast, but it is not as readable. And so that's why we're learning dplyr instead of data.table. But to the point, there are dplyr extension packages that make it easier to use or make it faster. And so the first one there is dtplyr, which is dplyr code that will run in the data.table R package. And so it's translating your dplyr code into data.table code to make it run faster. There's dbplyr. As I said before, these work like SQL. And in fact, if you want to write dplyr code that will then be turned into a SQL query, it does that with dbplyr. And then there's sparklyr, which translates code and interfaces with another thing that is faster and is in the big data world, which is Apache Spark. Okay. And so that is the end of my dplyr slides. But I want to take a second and come back and think about how we can start. We can't do everything, but how we can actually start working on these grades, because I pulled this up as a motivating example, but I would like to start to calculate those grades for just a minute or two. And so I have my fake grades that look like this. Okay, and so the first thing I want to do is I want to split them up into homeworks, quizzes, tests, do the computations there, then push them all back together, and then calculate grades. Okay, and so, well, the first thing I want to do is probably select. So I want to take grades. I want to select a few things. I have to keep the name of the student there. So I have to keep the name in order to keep the identifier where all the homeworks are. But if I just want homeworks, I'm using select, and I probably want starts with. They all start with HW. Okay, and so what does that do? Well, lo and behold, I now have just the homeworks. So you can see it starts here, but then it shows you the things down here. And so now I have the student name and all 23 homeworks. Okay, so select homework. Now, one more thing that I'll mention that is important is that when I run lines 24 and 25 right now, it prints out the result, but it does not save that result to memory. If I open up the environment, I only have one thing in the, well, I have two, the function f that I made in the functions video, and grades. And grades has not changed. So running lines 24 and 25 over here, execute the code, but it doesn't save it anywhere in memory. If I wanted to save this in memory, just as like homework, I would have to assign it to this. So now when I run this, now notice there's a new item in my environment, which is homeworks. Now that is saved somewhere. So whenever I do just the pipe stuff, so down here lines 33 through 35, again if I'm doing diamond stuff, when I run diamonds and I get this, it evaluates the code, but it does not save the result anywhere. So that's an important thing to keep in mind. All right, so now I have the homework grades. Okay, I have the homework grades. I have all 23 of them, and I want to find the average of them. Right now, we don't have the tools to do it how I want. Okay, there is a row-wise function that could help us. Basically, I could mutate. So I could mutate and I could add them all together. That by default, that probably takes us a little while. I'm going to show you what I would do very quickly. I'm going to show you what I would do with a tool that we'll learn about in just a second. And that tool is going to be, if I can remember it, it's called pivot longer. Okay. Basically, my data is wide, and I'm going to make it long. Now I have another video that will tell you exactly what pivot longer is doing. But just for the moment, I'm just going to write some code. Okay, now I'm going to take this away for the moment. Okay, so now I've created this data set. Notice that it went from 25 by 24 to 575 by 3. And what happened is now I have, not for this student, I have 24 columns that all talk about the different homeworks. I now have 25 different rows, and each row is a single grade. So student 1 got 100 on homework 1, a 60 on homework 2, a 0 on homework 3, 0 on homework 4, so on and so forth. Now, this is going to help us because now I have 24 rows per student, okay? And I want to find the mean of the grades column. But if I just do summarize mean of grades, and I call it the exact thing here, grades, okay? It was an 81, which is, well, not very helpful because that was over all of the students. And so what I need to do is I need to group by name, group by the student, and then the average for each student. And there we finally have for each student. So for student 1, their homework average was a 45.5. Homework 2, student 10, 94.1, so on and so forth. Okay. Now this is really helpful. So to go a little bit further, what if I, instead of just averaging all of them together, what if I said I want to drop the 2 lowest? Okay. If I add something like this in, my approach seems a little less odd. Because you're probably thinking that was a little overkill. 1, because I don't know the pivot longer function yet. But 2, why would I change the structure of the data set when I could have just mutated it? Well, now, what if I want to drop the lowest 2? That makes it a little bit harder. But it's actually not too bad. I now have, if I wanted to do that, I still have this, and I could arrange, just for viewing purposes at the moment, I could arrange by grades. And the interesting part about this is that if you look, it doesn't really help at the moment. Actually, sorry, I need to move that gives you all of the zeros. And I don't want it here. I want it after the group by. After I group by name, I could arrange grades. And when I arrange by the grades, oh, well, I'm sorry. It still doesn't help show you this. But, I guess, sort of. If you look at the names, it has all the students. So it's keeping student 1 first, then student 2, then student 5. It's keeping the grouping. It keeps the grouping. And so I could use something like the slice function. And I know that every student has, after I arrange from highest to lowest, maybe that'll be better, lowest to highest. If I went arranged highest to lowest, I could then slice, and we had 24. Sorry, we're back up here. I had 23 homework assignments plus the name. So 23 homeworks and a name makes us 24. So I could get rid of 22 and 23, which after I arrange should be the bottom 2. And it should give us, again, numbers that should be slightly higher. Up here it was, so student 1 had an average of 45.5, now has an average of 49.8 because I took away 2 zeros. Okay? So on and so forth. And so with this sort of splitting stuff, I can do that sort of thing. Now, we won't go all the way. We don't have all the tools yet, but we'll keep working on this example to help us find at least one use case of using these dplyr functions. So hopefully that was helpful, and that's the end of the beginning dplyr slides.